Good afternoon. I'm Euiheon Chung from Gwangju Institute of Science and Technology, and today I'm going to present automated quantification of Meibomian Gland dropout in infrared meibography using deep learning. Majority of work done was Mr. Vipon Kumar Saha, and our clinical support was done by Professor Ho-Jik Wang. So what is Meibomian gland? Which is a gland in the eyelid, exocrine glands along the rim of the eyelid. And you can see by using infrared camera, you can find out this revealing of the Meibomian gland of upper eyelid and lower eyelid. And some of these are lost that we call Meibomian gland dropouts, can be an indication for Meibomian gland dysfunction. So for that imaging, there are various imaging tools available for visualization, keratograph IM or lipid scan or Tear Science lipid view 2, and or do yourself imaging devices. For today's study, we use a lipid view 2 collected the Meibographs. So what are the challenges in Meibography analysis? So this, for example, there are glands and eyelid segmentation. There have been different adaptive threshold technique, but they have low accuracy and only work in uniform lighting condition. Also, you can see there are like specular reflections, which makes it difficult to identify Meibomian gland. Another is the currently no methods are available to create Meiboscore, so we are dependent on semi-quantitative clinicians' judgment for grading. And also, there's no data set, public data set available on Meibomian gland to perform research on this field and compare each other in terms of image processing. So we collected a patient data set, and we have this men and women with the Meibomian gland patients. And with that, we identify 1,000 potentially eligible images, and we divide them into 800 and 200 for deep learning training sets versus test sets. And these ones, 1,000 images were annotated by computer scientists under direct supervision by MGD Experts. And out of these MGD Experts were grading all these images 6 times with Meiboscore. So first, the investigator, they did the image annotation under the expert guidance. So this is an example. So original Meibograph and annotated by investigators like this. And also we annotate this eyelid area so that we can quantify all these one. So the parameter we are interested in MG area or MG area ratio of this MG area with respect to this eyelid area. So this is an example of labeling by investigators. You can see investigators did this labeling of Meibomian gland and also this eyelid as well. So first we did all these 1,000 images and we tried to find out the correlation of this over the age, which is known that upper eyelid and lower eyelid, both MG area and area ratio. We found that there is a tendency of decrease of this area over the age and the ratio as well. And then we turn into the Meiboscore grading. This is only done by MGD Experts, but we are curious about the consistency of the human experts. So for that, we've designed these 1,000 images to make a multiple Meiboscore scoring by first expert, and it did it for 1,000 images and wait for about a week gap to forget and then do it again by 3 times. And we did it for 2 independent MGD experts. So total 6 times of grading was done for these 1,000 images. And then we are curious about how was the intra or inter-variability of these scores by even these experts. And here are the results. So MGD experts 1 did the 3 rounds, 2 did 3 rounds. And the color shows the Meiboscore from 0 to 1 to 3. Majority of these are consistent, but you can see even within Intra experts, there are differences, and also between these experts or inter-variability. For example, this area you can see in this image, one image shows all 0, 1 to 3, all different kind of score results. And so there exists intra and inter-variability of the person, but machine learning would not suffer from that. So we use this average of 6 times of Meiboscore for training our machine learning for Meiboscore prediction. So we designed our deep learning model for this analysis. And with this input image, we basically use this annotation by investigators to predict Meibomian Gland and Eyelid with this machine learning. And in the end, also the Meiboscore can be predicted by our classification. So the parameter is MG area and MG area ratio of between these two. So we train our Meibomian Gland images with deep learning, and we were interested in how to define accuracy. So our investigators as a ground truth label and our deep learning output as a predicted label. So we use this accuracy as intersection over union, and here are the accuracy with respect to 90, 60, 40%, how it looks like. So with this, we can define the accuracy. So deep learning segmentation was done and shown in here. This original annotation was done, shown as an orange color and deep learning output as a blue color. You can see there are pretty good correlation and agreement. Only this eyelid was similar. So there has been a pretty good agreement. And for example, deep learning output for this predicted image shows this Meibomian glands, individual gland for segmentation. Also, we can predict its eyelids by deep learning model. And it shows between the human annotation, there's accuracy of 94% was achievable. So we were interested which ones are more accurate. So for that, we define the accuracy of between investigator to investigator, or the average of investigator and deep learning model. So the result is like this. So investigator and deep learning, the accuracy, you can see accuracies in general going up. And when we put all these 200 images, the difference of accuracy of deep learning minus investigator. So the positive means deep learning has a higher accuracy. So 167 out of 200 is higher than 0 or more accurate. So in terms of this accuracy on average, deep learning is 67% versus 64% higher. And in terms of Meiboscore accuracy, we are also trying to understand because we have two MGD experts for scoring. So 1 and 2 scoring, when they have intergrading accuracy, which is when they are the same scoring, we add up that results in 53%. But average Meiboscore of MGD expert versus our deep learning output, when we calculated the accuracy of deep learning shows even 73%, which outperformed for MGD experts. So MG area and MG ratio between investigator versus deep learning has been compared, which shows here there's a very good high correlation between investigators versus deep learning output. And even Bland-Altman plot shows to compare this, and we've got this 95% confidence interval of this difference shows no positive or negative bias or trend, which proves that our deep learning output is pretty good. And when we look at the image, there are specular reflections. So we were wondering whether deep learning can even fix this one. So we use global threshold to define reflection point, and we use a GAN or generative adversarial network to restore this missing part by reflection-removal architecture so that it can output the most likely information of this missing part from the surrounding image area. So this is an image example of original image which contains this specular reflection, but as deep learning corrected this one, which at least improves this image for clinicians to evaluate. And at the end, all these data set, we try to make it open to the public so that we can promote open research. So all the infrared 1,000 images and our investigators annotation of glands and also eyelids. So we create this 1,000 images of data set, and also the all gradings by 6 rounds of MGD experts are also included. Age and sex information are included, and which is put it in GitHub database. So this is the first image-based data set of Meibomian glands with precise labels for further open public research. So in summary, we've developed the automatic Meibomian gland visualizer. And second, we also automated the grading system of Meiboscores. And third, this specular reflection can be corrected by using machine learning algorithm. And in the end, we put all these image-based data set on the GitHub database on public. So the deep learning, in conclusion, infrared Meibography allows us fully automated, consistent, and fast quantitative evaluation of Meibomian gland morphology and Meiboscores, which will be useful for diagnosing Meibomian gland dysfunction. And this is the end, and thank you for your attention.